Hello students, welcome back to Venkat Gorla Tutorials. Today's topic is breathing and exchange of gases. Let's now discuss breathing and exchange of gases. Now how exchange of gases takes place? The exchange of gases takes place by diffusion at two places. Number one is at lung level, and number two is at tissue level. So lung level exchange of gases, tissue levels of exchange of gases. At lung level exchange of gases is present, it occurs between the lungs and blood, occurs between lungs and blood. At tissue level exchange of gases, it occurs between blood and tissues. Hope you all understand. So there are two levels. Level 1 is at lung level, level 2 is at tissue level. The level 1 occurs in between lungs and blood. Level 2 occurs between blood and tissues. Got it? Now, so how these gases is taking place? Exchange of gases takes place. So gases diffuses from higher partial pressure so gases diffuses from a higher partial pressure is represented as pp, to lower partial pressure. So gases diffuses occurs from higher partial pressure to lower partial pressure. Got the point? Now the rate of diffusion, it depends on the rate of diffusion depends upon, there are three factors. So what are the factors that are required? Factors of diffusion. Number one is partial pressure, or we can say that concentration gradient. Concentration gradient. Number two is thickness of membrane. Thickness of membrane. The membrane in the sense respiratory membrane. And number three is solubility of gases. Solubility of gases. So there are three factors which are involved in exchange of gases. They are called partial pressure or concentration gradient, thickness of membrane, and solubility of gases. The three are the factors which depends whether the gases rate of diffusion of gases will be increases or decreases. Now let's see what is partial pressure. Partial pressure. So partial pressure usually represented as pp. It means pressure exerted by an individual gases. The pressure exerted by an individual gas in a mixture of gases, irrespective of concentration of gases, irrespective of concentration of other gases, is said to be partial pressure. That means a pressure exerted by an individual gas in a mixture of gases irrespective of concentration of other gases is said to be partial pressure. The partial pressure of oxygen and carbon dioxide, the partial pressure of oxygen and carbon dioxide at table. Now let us see the table. Respiratory gases, inspired air, alveolar air, deoxygenated blood, oxygenated blood, expired air, tissues. So oxygen, respiratory gas oxygen, the inspired air is 159 mm of mercury. In alveolar air is 104 mm of mercury. Deoxygenated blood 40 mm of mercury. Oxygenated blood 95 mm of mercury. Expired air 116 mm of mercury. In tissues 40 mm of mercury. So the partial pressure of oxygen in atmosphere is 159 millimeter of mercury. The partial pressure of O2 in alveoli, alveolar air, that means alveoli of lungs, is 104 milli of mercury. And deoxygenated blood in tissues, it is about 40 millimeter of mercury. Oxygenated blood in the blood vessels, it is 95 mm of mercury. Expired air 116 millimeter of mercury. And tissues 40 mm of mercury. Now let's see this. A carbon dioxide. This is oxygen, partial pressure of oxygen. Now let's go without carbon dioxide, CO2. So partial pressure of CO2. The partial pressure of CO2 in inspired air is 0.3 mm of mercury. Alveolar air is 40 millimeter of mercury. Deoxygenated blood is 45 mm of mercury. Oxygenated blood is 40 mm of mercury. Expired air is 30 mm of mercury, and tissues is 45 mm of mercury. So partial pressure, as I told you, three factors. One is a partial pressure, concentrated gradient. Concentration gradient, usually the gases exchange from higher partial pressure to lower partial pressure, high concentration to low concentration. In such condition, what is there? Oxygen is atmosphere is 159, where in the case of what in tissues is 40. So higher to lower the gases is exchanging. Similarly, carbon dioxide reversible reaction from what in atmospheric air is what 0.3 millimeters, but in the case of tissues it is a 45 mm of mercury. So therefore, from the tissues the blood enter, carbon dioxide enter into the the blood capillaries, from there to alveoli, from there to expel to out, release it to out. So this is what a tabular column, a graphical representation of this tabular column. Now exchange of gases, and there are three factors, as we said that there are three factors. They are called let's see the factors. The first one is a partial pressure. So we know the gases are diffuser gases. We know gases or diffuse according to partial pressure. Example: oxygen diffuses from atmosphere having 159 mm of mercury, 159 mm of mercury to alveoli of partial pressure of oxygen is 104 millimeter of mercury. So as we learnt, partial pressure, concentration gradients. So in atmospheric air is having 159 mm of mercury of partial pressure of O2, that is transferred to what diffuses to alveoli of lungs, that containing 104 mm of mercury. The pressure difference 159, here 104. So another what factor is, as we said, the mentioned thickness of membrane. Thickness of membrane. The more thickness of membrane, if at all, more thickness of membrane, less will be the rate of diffusion. The membrane is more thin, the rate of respiration is higher rate of respiration, higher rate of diffusion, This is to be done by respiratory membrane. For efficient diffusion, efficient diffusion to occur, the membrane should be very thin. That means the thickness of membrane, is 0.2 millimeters. 0.2 millimeters. Next, the solubility of gases. There are two factors over here: high soluble and low solubility. High solubility is a higher partial pressure of O2, low partial pressure of PCO2. I mean, the solubility of gases is more soluble. The gas having more solubility, the more the gases will be diffuse. If the less solubility, a low amount of gases will be diffuse. A gas having more solubility diffusion has become more faster, or a gas having low solubility, diffusion occurs very slow. Example: solubility of carbon dioxide is 20 to 25% faster than oxygen. There are two sides of exchange of gases. There are two sides of exchange of gases. Number one is exchange of gases between alveoli of lungs and blood. Two is an exchange of gases between blood and tissues. Now let's see, the first one is the exchange of gases. That means external respiration external respiration. It means exchange of gases between alveoli and blood. Alveoli and blood. The wall of alveoli is very thin. The wall of alveoli is very thin and rich network of blood capillaries. Due to this, the wall of alveoli act as respiratory membrane. Thickness of respiratory membrane is 0.2 millimeters. The respiratory membrane consists of 3 layers. They are 3 layers. One is thin squamous epithelium of alveoli. Number 2 is endothelial lining of alveoli. Endothelial lining of alveoli, alveolar capillaries surrounding endothelial, is basement membrane. All 3 thickness is 0.2 millimeters thickness. 0.3 thickness. Now let's see this. For example, this is a membrane. What we can call it as squamous epithelium, and this we can call it as basement membrane, and this we can call it as endothelium. Number 1, 2, 3. This is called endothelial epithelium, squamous epithelium, squamous epithelium, basement membrane, and endothelial. Endothelial lining of alveoli. Pass. Another one is internal respiration. This exchange of gases, so it is present between the blood and tissues. This occurs between blood and tissues. The partial pressure of oxygen is higher. The partial pressure of oxygen is higher that is 95 mm of mercury than that of the body cells. Body cells containing 40 millimeters of mercury, and the partial pressure of carbon dioxide is lesser, that means 40 mm of mercury than that of body cells. Body cells, that is 45 mm of mercury. Therefore, the oxygen diffuses from capillary blood to the body cells. Through tissue fluid. And carbon dioxide diffuses from the body cells of capillary blood via tissue fluid. Now the blood becomes oxygenated. Now the blood becomes oxygenated. Now the blood becomes deoxygenated. So the latter is carried out. Later is carried to the lungs, heart, and hence to the lungs. The second is internal respiration. Internal respiration occurs in between blood and the tissues. the partial pressure of oxygen is higher, that is about 95 mm of mercury, than that of the body cells containing 40 mm of mercury. So the body cells containing 40 millimeters of mercury, whereas the arterial blood is containing 95 mm of mercury. So therefore it will be what and similarly the partial pressure of carbon dioxide, so lesser, that means 40 millimeters of mercury than that of body cells, it containing 45 of mercury. Therefore, so oxygen diffuses from capillary blood to the body cells through the tissue fluid, and carbon dioxide diffuses from the body cells to the capillary blood via tissue fluid. Now the blood becomes deoxygenated. The blood becomes deoxygenated, means impure. Later it is carried to the heart. Later is carried to the heart, hence to the lungs. So now let's see the diagrammatic representation of the exchange of gases between alveoli and blood to the tissues. Let us see the atmospheric oxygen. The partial pressure is 159, which enter into the lungs by the inhalation. In lungs, what is there? Alveoli. Now at alveoli the partial pressure of oxygen is 104 mm of mercury. I mean the diffusion of gases occurs between high partial pressure to low partial pressure. Atmospheric pressure is 159 mm of mercury, and lung level is, or else alveoli of lung, 104 mm of mercury. So due to the pressure difference, the movement has done, and the diffusion from the alveoli of lungs enter into the arteries. In that means partial pressure of O2 is 95 mm of mercury. From there it goes to pulmonary, systemic aorta, from the left auricle to left ventricle. From systemic aorta the partial pressure of oxygen is 95 mm of mercury. From these blood capillaries, the blood enter into tissues, where the partial pressure of oxygen is 40. So 95 to 40, that means high pressure to low pressure. Now that means the exchange is done, is taking place. Now from oxygen, so hemoglobin oxygen is separated, the oxygen is utilized by the cells and tissues. Now that from the tissues, the partial pressure of carbon dioxide is 45 mm of mercury. It moved towards diffusion to the blood capillaries. That means here the blood capillaries partial pressure of carbon dioxide is 40. That is enter into vena cava. This is artery or vena cava, and now vena cava, vein, either superior vena cava or inferior vena cava. Now the partial pressure of carbon dioxide from the superior vena cava or inferior vena cava goes to the right auricle, from right auricle to right ventricle. From right ventricle it goes to the pulmonary artery. From there it goes to the lungs. In the pulmonary artery, the partial pressure of carbon dioxide is 40 mm of mercury. From there it will be diffused to the lungs. In lungs, the partial pressure of carbon dioxide is 40 mm of mercury. From there it goes to outside atmosphere. In atmosphere the partial pressure of carbon dioxide is 0.3 mm of mercury. So thus the exchange of gases takes place. One is a lung level exchange, other one is tissue level exchange. This is all done by the concentration pressure gradient, means higher pressure to lower pressure, high partial pressure to low partial pressure. Similarly, carbon dioxide also move from high partial pressure from the tissues to low partial pressures to the lungs. From lungs it is expelled to out during the expiration. So this is the excess of gases that occurs in the lungs. One is from lung level, other one is tissue level. So hope you all understand this. If you like this video, please share and subscribe my channel. Thank you for watching.